Thanks for that intro. That was nice. I have a little bit more intro as it pertains to this talk. I've worked a lot on open video initiatives over the years with Wikimedia and Mozilla Foundation, ZIF.org as well, a few other open source video projects. We also sort of organize this thing called FOAMs, which I won't click through to because the browser's going to probably do something bad, the resolution we're at right now. But it's basically a group that meets pretty regularly to discuss standards for media on the web. And as he mentioned, I'm presently at Elation Crunchyroll. What are we gonna, excuse me, what are we gonna talk about today? We're gonna take a look at standards that enable premium video experience. And we'll take sort of a look at the technology behind them and how you could make use of them if you chose to. First, we should talk a little bit about like how we got here and where we came from. Originally, the video on the web was a pretty painful experience. It was very difficult to deliver video to customers, aside from the fact, and even for customers to actually watch said video. There was just sort of a lot of different, and even up till a few years ago, before HTML5 became more popularized, we had quite a few different plugins and systems in play that were, that made it complicated to deliver video to customers. I don't know if have anybody heard of these before. Basically, we had sort of smooth streaming, which was done with the Silverlight-based plugin. We had Adobe HDS, which was Adobe's standard, and then Apple introduced HLS thereafter. And all the set-top boxes or connected TV devices, if you had sort of a broader video requirements, if you're a larger service operator and you had to deliver video to customers with set-top boxes and that sort of thing, that was all completely different. And now that still is largely a complex mess. And then on the containers and codec side, we've also had kind of the industry is more or less consolidated now on the H.264, but leading into that, there was the other open formats. And now looking ahead, there's several competing codecs for playing video. Codecs basically just the algorithms that take raw video and make it smaller so it's easier to stream on a video. The delivery protocols listed are what take that video and put it into little chunks so that it can be sent to users. This is one of my favorite XKCD comics. Sort of how did we get here? So like if you were to look at this slide, ironically, now we have Dash, which is a new standard that was supposed to capture all of the standards before it. But we are making progress in that sense. Some of the newer standards nowadays are more broadly adopted, and we have broader adoption and acceptance, by major entities. I think there was a lot of talk about HTML5 prior to the iPad and Flash being excluded from the Apple's products. But I think standards really get driven forward once, ultimately driven by implementation and market share, right? So if a large company pushes forward on a standard, that kind of makes it happen more so than a lot of people talking about them. And today, of course, they're pretty universally recognized. If you look at any of the, pretty much all the major players, all the major browser vendors, all the major device manufacturers, all sort of aligned. This conference is about mobile, so we're going to focus in on the mobile video aspect of this. Mobile video, of course, is overtaken PC viewing by quite a bit in the past few years. Connected TVs also have similar reach to PC as it pertains to video nowadays. And mobile web is an important aspect of that. So there's the native app context where you have a lot more flexibility to do whatever you want in terms of just all those different protocols could have been supported, or all those different codecs can be supported when you're in a native environment. You have more flexibility. But as we're moving towards mobile web gaining broader and broader use, we have to think about how we can deliver these premium video experiences in the context of mobile web, because it has a 4x or so reach. This is just from ComScore. These are the top 1,000 sites versus the top 1,000 apps. You can see that a lot more people are consuming mobile experiences through web engagement. There's some other slides in here too that are not on this deck, but a lot of that web engagement is often through a wrapped view, like Facebook or Twitter, like you're clicking through on web links often. So what are we talking about when we say premium video experience, and how do we deliver that in a mobile web context? We're talking about adaptive streaming. So that's where you have lower level control over the buffer that basically stores the video before it's played. We're talking about protected content, which is sort of digital rights management, the DRM schemes that are used to protect content before, so to make it more difficult to copy and pirate. Seamless ad insertion, so being able to load ads ahead of time and insert them into the video playback experience so in such a way that they don't result in fall off or ad abandonment. And then finally, like low latency live video is something that's of interest. The standards we'll be taking a quick look at are MSE, EME, the Media Capabilities API, and looking towards HTTP2, which is another standard, and these sort of map more or less to these premium video requirements that we were discussing a moment before. It's important to note that when we're looking at these things nowadays, HTML5 standards are across the board. It's not just mobile, but it's everywhere else. So the vertical integrated platforms basically mean that the browser that's running on your phone is actually the same code of the browser that's running on your desktop nowadays. Same with the browser that runs on your game console is the same one that runs on your Windows PC, and so on and so forth. Media source extension is basically the mechanism in which you can have lower level control over the buffer or the data that before it gets put into the video tag to be played. It's pretty critical because of the ease in which you can sort of context switch within a mobile experience. There's really like a low tolerance for long buffer times. So you can see these are some data points around TV. Whoops, where's my mouse here? TV having a much longer startup time, yet a much lower abandonment rate because you've already invested in it and it's not easy to context switch. But where you're accessing things on even on a Wi-Fi mobile, you may have a quick startup time, but higher abandonment rates because people context switch. And so MSE is important to enable you to control that buffer so you can minimize the amount of time it takes to start playing video. What does it do? It's basically a source buffer that you can append video data to. This is different from like just the normal video tag. I don't know how many people have looked at the video tag before, or the image tag. Has everybody seen an image tag before? Like image source equals something? Okay, there we go. Yeah, so that same sort of thing, but instead of pointing directly to the entirety of the video, we're just putting pieces of it in bit by bit, and this lets us control the buffer flow essentially. And also enables adaptive streaming and sort of that ad insertion we talked about earlier. And the API is fairly straightforward. It's basically you just grab your video tag element. It's a little blurry with the resolution that we have here, but hopefully it's readable. Yeah, you basically grab the video tag, you create a new media source, and then once you can get some data. However your data is flowing through your application, you can grab it and then append it to the media source. This is really gives you a lot of flexibility to combine it with other HTML5 video technologies. So things like the what do I say, local storage, for example. If you want to build an offline player, that's possible because you're just sort of grabbing data and appending to the source buffer. Or if you want to build a peer-to-peer video delivery system, you can take a peer request and take that data and put it into the source buffer. There's just lots of options towards supporting that. Once you have that data there, you can just sort of append it to the video and play the stuff back. The other one we're going to take a quick look at is encrypted media extension. This is basically the mechanism to deliver protected content. So things like premium movies, or when if you're a republishing content or a content publisher, often there's licensing requirements around protecting that content. And this basically is a mechanism to enable that protected content delivery in a web environment. That sort of thing maps to this architecture diagram, which again I think is going to be a little difficult for folks to see at the resolution. But basically, it sort of standardizes the way in which you interface with a black box, which is the content encryption module. The content encryption module in the media framework is sort of the black box that you pass media into, and then you get playback. Well, you pass media and the key, of course, into that content encryption module, and then you get back a opaque video stream. And that opaque video, I say opaque because essentially none of your code can access the pixels that are coming back. You can just play it back, essentially. And it actually has implications in the way that it interfaces with the rest of the HTML API. So you can't do things like throw it on a OpenGL surface, or grab it and manipulate it using the canvas data. I don't know. I mean, there's a lot of implications on how it works, but at least fundamentally, you're able to display this protected content in a relatively unsecured environment. And how does it work? It's pretty well, straightforward. As convoluted as this code looks, it's worlds simpler than some of the other DRM schemes that were implemented in native code prior to the arrival of EME, because there was DRM especially was susceptible to really dramatic alternate implementations because it's sort of a security by obscurity process. Here we're just grabbing the again, we're grabbing that video tag here. Excuse me. Grabbing that video tag and basically assigning a key access system. In this case, clear key. This is just sort of the shared implementation that you can test against arbitrary browsers. Normally, this is like Widevine or PlayReady or one of the or FairPlay in the case of Apple. And then once you've established the access scheme, you can basically supply the token or the license, and then basically that stream should be playable within the video tag. Media Capabilities API is another interesting one. This one was actually discussed in that workshop. Well, all of these are discussed, but discussed a lot lately in a recent workshop, where we're trying to sort of extend what we have with can play type, and this is useful where you're trying to map in new capabilities. So as we start to introduce more and more premium video features, things like high dynamic range color content, or 4K resolution, or requirements around HDCP, which is the sort of goes back to the DRM discussion. I don't know, just look at that really quickly just so people have a sense. Like the DRM system is basically secures every connection all the way to the the screen itself, which has a special standard for receiving an encrypted HDMI signal, and hence you need to be able to query that information in order to select among streams. And so the way that this maps out in practice is things like having maybe you'll have a 4K version of your content, and that would be have tighter restriction requirements versus like the SD or medium resolution or the 720p version that goes through a less secured pipeline. And then finally, we're looking at sort of low latency live streaming capabilities against these standards. And why do we care about that? Live streaming, of course, is a huge part of online video. And we're thinking, how we can deliver that in the same way across many platforms, reducing the cost to bring it to market, and again, without having to force the users to install a native application, especially for sort of live content. If you imagine somebody is, scrolling through their Facebook or Twitter feeds, and they're going to just click on something, they don't want to necessarily have to install another app to begin to engage with your live content. In the case of this standard discussion, we're talking about lower latency live streaming, and here we're looking at trying to reduce this time, right? Normally, the way that video is delivered through the internet is through a manifest, and you send a manifest, and it has a list of the different segments. So the video is basically broken up into little segments, usually 10 seconds, but in the case of live video, it's usually shorter, maybe 3 or 4 seconds. And basically, you're trying to, with the adoption of HTTP2, we're trying to reduce the amount of time you have to wait before you get each segment. And because HTTP2 supports push, which is a protocol to push out the segments, so you don't have to wait for the user, or in this case, the client's player, to request the segment. You can just start pushing them out. And this enables you to reduce the overall latency while still delivering video over a standard CDN network, which is important for scalable video delivery. How do you use HTTP2? It really depends on your CDN's implementation. Here's some examples from, I think, Cloudflare. HTTP2 has lots of uses beyond, obviously, not just about media. In fact, it wasn't designed with that purpose. It's more about updating the way that we deliver web pages and web content. And there's a lot of mechanisms to basically accelerate that delivery. So you can sort of tell your web page, like, these are all the resources that you're going to need. Don't wait for the client to load the HTML, parse the HTML, send back a request with the HTML resources that are identified. You can just sort of send them all at once, which you see happening a lot today on high-performance web applications, especially from Google and others. And basically, it just means you're able to sort of tell the client ahead of time what it should be downloading. In this case, they're just setting a header, and it's pretty straightforward. They're setting the header there and playing back the content. And I think that was the whole thing. I don't know how much, if I'm on time or off time here, but so it's kind of a general overview of